Okay, final one. We are looking at Unit 10 review. Now, I am legitimately looking for this one to be quicker than all the other unit reviews for the very reason that I'm not doing lecture notes beforehand. I'm jumping straight into practice problems. I'm doing that for two reasons. One, because they're all kind of connected reasons, but one, because we just did this unit. And when we just did this unit, you had this cheat sheet, the circle stuff one. So I'll refer to this as I need to, but this is all the stuff that it's kind of all the stuff you need to know with regard to rules. There are a couple others that can pop up here and there. And the first set of problems kind of runs into vocabulary. So it's kind of good. It's kind of a 2-for-1. So I'm going to do all these now, see what kind of time I can get through on this, and just go ahead. Okay, number 1, name each part of the figure listed below. O is the center of the circle. No part can be used more than once. So cool. We're going to check and see which things are which. AB is a minor arc. Right there, that guy. Minor arc is less than 180 degrees, and it has a 2-letter naming reference. Angle A, this little angle A right here, if O is at the center, this is a central angle. It is formed by 2 radii. I'm sure we're about to run into a radius here. OD, here we go. Here's your radius I was referring to. That is a radius. Angle B is right there. That goes from vertex to end of circle in both points. There's endpoints. That is in an inscribed angle. Inscribed angle's vertex is on the circle as well as its endpoints. I think they could have named that one better, like angle ADB or BDA. Segment EA. EA, this guy out here, it goes and it touches the circle at one point. This is called a tangent line. If it kept going through, it would look like that. Touches at one point. Tangent. They just call it tangent over here. DB is a chord, but it's a specific chord. It's a chord that goes right through the center of the circle. That is a diameter. It's the longest chord you can make in a circle. AD is a shorter chord, and it is just any other sort of chord. So this guy, a little shorter, is called a chord. DCB, you can see that it goes through, and you'd assume that it's a major arc because it has a 3-letter assignment, or a 3-letter name. Goes D to C to B. But DB is the diameter, so DCB goes only 180 degrees. It's not a major arc. It's a semicircle. Although I do like to see semicircles have 3-letter assignments, otherwise I might go DB that way, DAB. DFB would have been the same thing. And finally, ray EF. EF continues to go through. It hits the circle once, twice, and goes all the way through. That is called a secant line. Here it's just secant. Okay. Sector, major arc, and radius. No, let's see, radius was used. Radius is right there. Sector and major arc were not used in this instance. An example of a major arc would be DAC, all the way around like that. An example of a sector would be something like this, a portion of the circle. Okay, number 2, what is the length of AB below the circle O? Now this is incredibly important. This is not just measure. The measure of AB is 90 degrees. That is not what they are asking for. So 90 is the wrong one. That would be measure. Length is in terms of how long is this with a tape measurer. If you take a tape measure, that's 6 centimeters. How long is that? So what you're going to do, this is kind of the same thing as sector. When you take the area of a sector, you're saying what fraction is the area of that circle out of the area of the entire circle. I'm going to do the same thing here. I'm going to look at this arc and say, how long is this arc compared to the length of the entire circumference of the circle? So this fraction, this is 90 degrees of all of 360. So we're looking at 90 out of 360, which is 1/4. We're going to simplify that soon. Equals our unknown length, AB, arc, over the circumference of the circle. So that's what we're going to put there. The circumference is 2 pi r, which is 2 pi times 6. 6 is your radius, which is 12 pi. So your radius is 12 pi. Okay. At this point, you could cross multiply, but I'm going to reduce this here. So it says 1/4 equals AB over 12 pi. And then now you can cross multiply. 4ab equals 12 pi, so ab equals 3 pi centimeters. Okay, so it will be b. Now, the big thing I want to put here is when you look at circle stuff and you see that they talk about this, it's right here, arc length. Okay, the way they write it is a little different. This looks a little stranger to you because it's not set up to look like this. Okay, but these are both the same thing. This is when you multiply both sides by 2 pi r, not just cross multiply, but you see that in front right there. So this is probably a better way to look at it for some people, especially this problem, because this is just 1/4. So let me put it this way. 90 degrees is a quarter of 360. So I want to look for the measure of this that's a quarter of 12 pi. So what is a quarter of 12 pi? Well, 1/4 of 12 pi is 3 pi. Sometimes you can look at it that easily because of how you say this number, but sometimes it's like 87 over 360, and you're like, 87 360ths of 12 pi. And at that point, you just cross multiply and do what you need to. Okay, but that is length. Length, not measure. Number 3, what is the measure of angle A in circle O? Okay, O is at the center right here. You have 112 degrees as a central angle. So that means this arc measure out here is 112, just this guy right here. Now, what I am looking at right here in purple is a diameter. Because this passes through circle, because this passes through the center, this must be a diameter. So this length plus this length equals 180. So the length, so the arc measure I'm looking for right here is going to be 180 minus 112. 180 minus 112 is 68. So this here is 68 degrees. Okay, hope you picked up what I was talking about there. I'm actually going to delete all this other stuff. I don't need it now. What I do need is angle A. The reason why I did that is because A is an inscribed angle, and its intercepted arc matches at these endpoints right here and here. So its intercepted arc is 68 degrees. That is angle A. Once again, I'm going to draw it out here. There's this intercepted arc. Just look at the purple, going with the blue. An intercepted arc is half the measure of its, an inscribed angle is half the measure of its intercepted arc. So angle A is half of 68, which is 34 degrees. Okay? Number 4, which equation can be used to solve for x in the diagram below? Okay, I'm going to save you time with regard to everything you need to know here, but you can refer to the circle stuff sheet and find it. This is with 2 secant, not right there. This is with 2 secant line segments down here. You get the outside, external, I call it the outside. External times the whole thing. So R is external. R plus Q is the whole thing. Equals T, external, times the whole thing, T plus S. So outside times whole thing equals outside times whole thing. So let's go ahead and do that. On top, I'd have 5 times 5 plus 7, the length of the whole thing. 5 times 12. You can write 5 plus 7. I'm just going to write 12. Equals 4 outside times the whole thing. Whole thing is 4 plus x. I cannot reduce that value, so it's, 4 plus x right there. And then, they just ask you to set it up. That's exactly what, this is x plus 4. This is the same thing right here. You do need to know that addition is commutative. X plus 4 equals 4 plus x are the same thing. So don't worry about which way it's written there. But this one applies correctly. Okay, this is a problem that we did in the Mars task, right? This was something that it was, I don't know if this is going to be the exact same thing, but it's going to be close. At the marine park, dolphins are trained by trainers to swim in straight lines. 4 trainers, Antonio, Bethany, Cindy, and Dominic, are positioned around the dolphin tank. So they're people. Here's the pool water. One trick is to have the dolphin swim to each trainer, receive a treat, and swim to the next trainer, and so on. The dolphin started to Antonio, then swam to Bethany, over to Cindy, across to Dominic, back to Antonio. So A, B, C, D, back to A. Draw the path the dolphin traveled on the circle above. Mark X at the point in the water where the dolphin crossed over its own path. So you'd probably use a ruler or something, but it's not drawn to scale anyway. Just know that these are endpoints here. So it goes A, B, C, D, and back to A. Okay, so we got that one. Check mark that off. Next question, how are AX, oh, it says mark X. So X is where this intersection point is right here. It asks, how are angle AXD and angle CXB related? So here's AXD, here's CXB. These guys are congruent because they are vertical angles. That's kind of all you need to say on that one. Explain which of the two angles, ABC or CDA, has the longer measure. So you're looking at ABC right here and CDA right here. Okay? Now, this was a problem that you had on your Mars task, which before I said you won't know the answer to it, or at least if you stumble upon it correctly, you won't have a valid reason. Now you do. This is a vertex on the circle and a vertex on the circle. They both share endpoints A and C. That is to say, their intercepted arc is this minor arc AC, both of them. These are both inscribed angles with the same intercepted arc, so these two are congruent. Angle ABC is congruent to angle CDA because they are inscribed angles with the same endpoints. Okay, I hope that makes sense now that you've done some practice with this stuff. You have to recognize, though, that despite all of the things that cross through each other, like all this X stuff, you are still looking at an inscribed angle here and an inscribed angle there. So something to keep in mind. Okay, what is the relationship between triangle AXD and triangle CXB? Clearly explain or prove. Okay, we have enough information for me to say what I need to say. Here's some important stuff I do want to say, though, prior to that. X is not at the center. There's nothing to assume or prove that, so there's nothing to say these are radii right here. So you can't prove any side's congruent here. I have no information to say that. But as I draw a two-column proof, I will say this. And we practice two-column proofs extensively lately. This is only going to be a three-step thing. We have these two things. They're not given, but we now know that they are. We know that AXD, I should have put this. AXD is congruent to CXB because vertical angles. So, step one, angle AXD is congruent to angle CXB. Vertical angles. Vert angles. Number two, up here, ABC is congruent to CDA because they're inscribed angles with the same endpoints. I'm just going to put inscribed angles, and hopefully you know what I mean when I put that. And finally, number three, now we have two sets of angles congruent in two different triangles. We could also go ahead and say that this and this are congruent for two reasons. One, you could have said third angle theorem. These have to be the same thing if these two are congruent. That's just how they add up to 180 degrees. And two, inscribed angles, once again, of this minor arc dB. Right? This is an inscribed angle with this intercepted arc. This is an inscribed angle with this intercepted arc. They're the same. So you could have given that reason. But angle is enough. We don't need angle because angle implies angle. So triangle, AXD, assuming they wrote the letters in the correct order. I'm sorry, not congruent. AXD is similar to triangle, CXB, because of angle similarity. So we now know that these triangles are similar, and there are corresponding angles which are congruent. There are corresponding parts which share similar side ratios. So I'm going to mark those up. AXD is AXD right there. CXB is CXB. So I'm going to mark these things, and they're going to be squiggly lines. They are not congruent, but they share side ratios which correspond with one another. That's what I'm trying to mark up as I do this. Those are not S's. They're just squiggly lines to imply similarity, not congruency. AX is not congruent to CX, but AX over CX is equal to DX over BX. That side ratio, do is do, or do is do, whatever. There's a similarity thing you can do there. Or, we've done this product stuff before. Check out your circle stuff sheet right here. When two segments intersect here, that cross multiplication. A times B equals C times D. So we're going to run into that right now. I set up the proportion that would give you that kind of thing, but that's what we're going to work with. Okay, the dolphin is currently at point... All right, so they give you the circle again in case you want to redraw and rework their stuff. It's the exact same stuff as before. These triangles are similar for the same exact reasons. Okay. Maybe I don't know if I'll mark that up again. Let's see. Dolphin is currently at point X and is a distance of 36 yards from Antonio. So X is 36 away from Antonio. If AB is 88 yards and XD is 40 yards, so this is 40, this is 88. Now remember, this isn't a diameter, but I still will figure out what this length is here. This is 88 minus 36, which is 52. So let's see. AX is 36. BX is 52. DX is 40. CX we do not know. Okay? This is our, well, I'll call this Y because I already have an X right there at this point. It says, how far is the dolphin from Cindy? Okay, one thing that I do want you to make sure that you know is that X is not at the center, and these are not diameters. So it's not like if this is 88, then this is also 88. That's the big thing I want you to take home from that. Only if they both cross at the center would that ever be true. But we do have this proportion here. This times this equals this times this. If you don't believe me, you can go back to this proportion setup right here. We set up this proportion. You may cross multiply as you do it. Let's go ahead and do that actually. AX over CX equals DX over BX. So AX over CX, I'll just put a question mark. No, I'll put Y. Equals DX over BX. And when you cross multiply, you'll get 36 times 52 equals 40 times Y. So again, Y times 40 equals 36 times 52. So it does still come into play the same exact way. So let's go and calculate that. I got 36 times 52, and I'm going to do that divided by 40, and I'm going to get a value for CX or Y or whatever that is 46.8 yards. It's a decimal. So it's 46.8 yards away from C right there. Okay? Moving on over. Number 6, carefully look at circle G, shown to the right. If measure of arc CE is 106, so I got this guy. It's 106 right here. And measure of angle A is 32 degrees. Then find measure of arc BD, show all work. Okay, this is one of those things. Again, I'm not going to reference how it comes to be, but if you treated it as an inscribed angle, you'd find the intercepted arc of what it is. I'm probably just talking right now and you're not getting through what I'm saying. But it's enough for me because I've explained this before. It's with two secant lines right here. You're going to find half the measure of this arc minus this arc. Half of that measure, B minus A, over 2. But again, if you do have trouble with that, please go to the circle stuff video. The circle stuff video will explain that concept right now. So I'm going to call this X. So my angle measure equals half the measure. They put over 2. I'm just going to put half. Half the measure of 106 minus our unknown arc X. Multiply both sides by 2. That'll cancel out my 1/2 here. So 1/2 times 2 is 1. And 2 times 32 is 64. So 64 degrees equals 106 degrees minus X degrees. Add X to both sides. Subtract 64 from both sides. 106 minus 64 is 42. So X is 42 degrees. This arc right here is 42. This angle 32, arc 106. Number 7, carefully look at circle G, shown to the right. If KM equals 5, so this portion right there, CM equals 11, and KE equals X, then find X, show all work. Okay, this is another example of outside times whole thing equals outside times whole thing. The only difference is that this outside meets till E, and the whole thing is E as well. So right there, that whole thing is still X. A secant intersect with the tangent line still has the same properties in the circle stuff area right here. Where'd it go? Right here. The outside times the whole thing, r times r plus q, equals the outside times the whole thing, t times t plus 0. There's nothing on the inside, so the whole thing is still t. So r times r plus q equals t squared. I don't need to memorize it like r times r plus q equals t squared. I just need to know the outside times whole thing is outside times whole thing. So 5 on the outside here times whole thing, 5 plus 11 is 16, equals x squared. Outside times whole thing, x times x. 5 times 16 is 80. So 80 equals x squared. Take the square root of both sides. You will get x equals the square root of 80, which is equivalent to, well, it's the square root of 16 times the square root of 5. We just kind of looked at that right here. Square root of 16 times the square root of 5. Square root of 16 is 4. So that's 4 times the square root of 5. Okay, units. So you could put a decimal approximation. I'm not sure if a multiple choice problem probably wouldn't give you that. Just make sure you know that. Simplifying that, you would have to, if it was multiple choice, it would probably show 4 root 5 and nothing else. Make sure you do get that. Now, it's not going to be plus or minus 4 root 5. Remember, if you take the square root of a value, it will be plus or minus. Problem is, length can't be negative. We can only refer to the positive version. Okay, number 8. AB is a diameter, so it crosses through C. Make sure you understand that. Of circle C, DE is perpendicular to AB, so automatically you want to draw a right angle right there. You're saying, okay, probably have to do right triangle stuff. If AB is 26, so the whole diameter is 26, and CF is 5, I'm going to actually zoom in on this problem because it gets really small. Look at 200%. Whoa, that was not very much. Let's look at 300%. There we go. So they say CF is 5. Then find the, okay, this problem zooming in, find the length of chord DE. Okay, DE is this entire chord right here. So there are a few ways I could do this. I want to stop for a second and look at it and see if there's a better way to do it than a worse way. Okay, I have decided on a way I want to do this. There are two ways you could have done this. You could have done right triangle. Well, actually, you know what? Yeah, here, I'll show you both ways. First way I'm going to do is create a right triangle by drawing this over here, CE. Okay, but this, excuse me, this all comes through one idea. And the one idea is that when a perpendicular, when there's a perpendicular chord drawn through another chord that passes through the center. So when this diameter goes through here, it becomes a bisector of this chord right here. So this is divided into 2 equal parts. That's the big thing I want you to make sure you know. If I call both of these x, I'm trying to find the length of DE, which is 2x. So I'm going to find out what 2x equals in the end. First, let's figure out what x equals. So to figure out what x equals, I need to know this length CE. Now, CE is a radius. It goes from center to endpoint. This radius is half the length of the diameter. If the diameter is 28, then the radius is 26, then the radius is 26 over 2, which is 13. So CE is 13. So now we're looking at a right triangle. Check that out. A right triangle with lengths 5 and 13, and we need to find x. Pythagorean Theorem would say 5 squared plus x squared equals 13 squared. But to save you time, you can do the calculations, but to save you time, this is a 5, 12, 13 special triangle. So x will equal 12. Okay? If x equals 12, 2x equals 24. So the length of DE is 24. Okay? Now I'm going to keep that up for 1 second, and then I'm going to say there's one more way to solve this problem. So go ahead and go back if you have to. But I'm going to erase what I just had and remark this. Okay? Second way to solve the problem. They say AB is 26, CF is 5, and this is a right angle. So again, the same thing, perpendicular stuff right there. I probably should have just erased that. Because I still am going to find, if these are both x, yeah, I don't know why I erased everything. But just rewriting it, these are both x, I still want to find what 2x equals, but I'm going to do it a different way here. Okay, whoops. Well, we know the answer will be 24, but we'll we'll see how that comes to be. Okay, if this this is again chord intersecting chord. Look at chord F, or not chord. Look at segment BF right here. I want you to figure out what the length of BF is. Okay, if this is a diameter, then this is radius right here, CB, which is 13. Right? We established that with CE. So this is 13. So chord BF here is 18. 13 plus 5. If the whole thing is 26, then FA right here is 26 minus 18, which is 8. So AF equals 26 minus 18, which is 8. These are both the same thing. I don't know what they are, but DF equals X, and FE, or EF, EF, to keep F's at the end, equals X as well. Okay, we go back to this relationship we did before, earlier. Broken parts, A times B equals C times D. Broken chords intersected together. So the two segments of broken chords being multiplied together equals the two segments of the other two chords being multiplied together. So that'll be this times this, x times x, which is x squared, equals 18, right? This whole thing's 18 times 8. So x squared equals, let's see, 18 times 8 is 144. So x equals the square root of 144, which is 12. If x equals 12, 2x again equals 24, which is DE. Okay, so we got DE one more time. Very good, very good. Questions on that? Check it out. There's two different ways we solved that one. All right, I'm going to zoom back out again to the whole page width. Okay, the regular decagon shown at right is inscribed in circle O. So circle O means O is at the center. If it's inscribed, it means all these things are inscribed angles. They touch at all those points. And AB equals 8. So this is the length of AB, not the length of segment AB, not the chord. So this is 8. Let's find each of the following. Measure of angle AOC, the central angle right here. Now it's not going to be all dependent on 8 right here. It's more dependent on the circle. Think about this circle is a decagon. A decagon is 10. Well, I'm sorry, the thing's not a decagon, but these are radii being drawn from the decagon. So I want to look at all these central angles right here. Now there are 10 of them because a decagon is 10 sides. So there are 10 of these. If I find the measure of one central angle and multiply that by 2, then I'll get this angle measure right here. So measure of angle AOC, I'm going to find a measure of angle AOB first, right here, just one central angle. That's 360 over 10, which is 36 degrees. 36 degrees times 2, two central angles, equals 72 degrees. So measure of angle AOC is 72 degrees. Okay. By the way, all of these, because it's a regular decagon, all of these things are 8. Not only is AB 8, but BC is also 8, CD, etc. I'll use those if I need to. Okay, measure of arc AB. Arc AB is just this guy right here, and it's not the length, it is the measure, so it's the same as the central angle. If the central angle is 36 degrees, then the arc is also 36 degrees. So measure of arc AB is 36. Measure of arc AE. So that goes from A to E all the way over here. It's still a minor arc, but it's significantly bigger. You can do this one of two ways. They're both the same thing. Either take this arc and multiply by 5. No, 1, 2, 3, I'm sorry, 4. Or take this angle measure and multiply by 1, 2, 3, 4. Right? Because that central angle is the same as its intercepted arc. So measure of arc AE is 36 times 4, which is 144 degrees. Okay, measure of arc AHC. You see 3 letters. It means it's either a semicircle or major arc. Looks like it's a major arc. A, H, C. So it's a pretty big one. So you can do this one of two ways. You can either multiply, because remember, these are all 36. You can multiply 36 by the number of these. Or you can say, if this one is 72, right, this one right here is 72 degrees, This one is 360 minus 72. I'm just going to do it that way. You can do it the other way if you'd like. It doesn't matter. 360 minus 72. Unfortunately, I don't know what that is. Was that 288? 288 degrees for our measure of that arc that goes all the way around. So again, the other way is 36 times, I guess, 8. 36 times 8 must also get you 288. Okay, measure of angle AJI. Okay, that's this guy right here. AJI. Whoops, the angle. That's this guy. Okay, here, I'm going to erase some stuff, actually. Let's see. Let's delete what I have in red. I just want to look at this angle right here, AJI. Now, there are a couple ways you can look at this. I'm gonna do it in terms of circles, because it's the circle chapter. I could have looked at it with the areas of hexagons and stuff like that. The way this is going to work is, believe it or not, it's hard to see it, because we see it normally like this. Like, see how this is an inscribed angle? Okay, this is also an inscribed angle. It's harder to see, but this inscribed angle is a vertex at J, and its endpoints are A and I. So its intercepted arc is this guy in green, all the way around right here, just like that. Okay, if it's whatever measure its intercepted arc is, AJI will be half the angle measure of whatever this is. All right, you'll know this because you'll know that AJI has to be less than 180 degrees, right? This is 180 degrees right here. So your answer is going to be less than 180. I hope you recognize that as you do it. Now, AEI, or whatever you want to call this arc, is the same as AHC because this is 72 degrees, this arc. I'm sorry, the arc is 72, just like this one right here. It's two of the arcs. So this is 360 minus 72, which is 288. So measure of arc AEI, or whatever you want to call it, it's just a major arc, is 288. So measure of angle AJI is half of 288. 288 over 2, which is 144. 144 is less than 180 degrees. I'm going to accept that answer. Okay, and finally, the length of AO. Ooh, that's a tricky one. AO right there. All right, what I'm going to do is delete everything, except I want you to keep in mind this is 8 and this is 36 right there. Actually, I'm going to do this a little bit differently. I'm going to rotate this thing. AO is the same thing as HO or anything else around there. I want to make it something new so you can kind of look at the right triangle in a different light right here. These are all radii. I'm going to draw it all down here. Just refocus it. So what I'm going to draw are two radii. One radius is going to be less important over there. And then I'm going to draw out a full right triangle for you. Whoops. Full right triangle like so to find out what all this is, because I do know a couple things. I know that this is a right triangle. I know that HG is 8 because AB was 8, so all these are 8. Remember we talked about that. Now if HG is 8, then this little guy right here is 4. This whole thing, the central angle, was 36 degrees. So half of that, right on the inside, right here, is 18 degrees. It's going to be half of 36. And I need to find the length of one of my radii, like this guy right here, x. It said find AO, but HO or OH is the same thing. Okay? So x right there, so x is right there. I can use trigonometry now. I know this is 18 degrees. Here's the 4, here's the x. There are probably different ways I could have solved this problem with the circle stuff, but I'm gonna keep it. I'm just gonna do with what you can practice with trig. We haven't practiced too much trig this semester. So sine of 18 degrees equals 4 over x. I'm using sine, SOHCAHTOA, opposite over hypotenuse. So x equals 4 divided by sine of 18 degrees. That's an exact answer. They might have that on a multiple choice problem, but if you had to round it, you'd get 4 over 18 sine, which is 12.94 units, I guess. I don't think they have a unit thing. 12.94 units, about almost 13. No, it doesn't have units. Okay, and final side right here. Let's see how quickly I can get through this. Circle O is tangents, AC and BC. Tangent lines with radii automatically mean right angles. I need you to know that. Well, it's not part of the circle stuff. That's the problem. So that's why I need you to know it. Measure of angle C is 48 degrees. That's this one right here. Find measure of angle AOB and measure of arc AXB. Explain or show you find your answers. Okay, I'm not going to beat around the bush here. The quadrilateral adds to 360. If these two are 90, then these add up to 180. So these two must add up to 180 as well. So 48 plus measure of angle AOB equals 180. Subtract 48, measure of angle AOB equals 132. So this is 132 degrees at AOB. Now this is circle O, so the center is the O is at the center. This is a central angle. If the central angle is 132, then its intercepted arc is also 132. So this is 132. Now they're asking you to find the measure of arc AXB, this major arc. Well, this plus this equals 360. So measure of AXB plus 132 degrees equals 360. Subtract 132 from both sides. Measure of arc AXB equals 228. 228 degrees. I could have given myself more room there. But yeah, this whole thing is 228. And again, I'm going quickly because, as far as moving on over, not re-explaining it, because you can hear the explanation again. You can rewind if you need to. And I'd rather save time. Okay, in circle P, AB is diameter. Measure of angle CPB is 52. So that's a central angle. So this is 52, which automatically tells you this is 52. You might as well do all the things that you can once you get information. AB is parallel to EF. So these two guys, what's the parallel? So these two guys are parallel. Let's see how that comes into play. Probably alternate interior angles. And measure of arc AE is 36. All right, so we got a lot to work with here. So this is 36 degrees. This is probably going to be an answer later, but I want you to know this is an inscribed angle then. F on the vertex. Intercepted arc is 36. So this is 18 degrees inside here. Again, inscribed angle. Find each of the following. Okay, measure of arc FB. FB, right here, has an inscribed angle of A. Okay, here's where this stuff is going to come into play. These lines are parallel. Here's a transversal cutting through that. So these are alternate interior angles right here and here. EFA and FAB are alternate interior angles, so they are congruent. So this is 18. If this is 18, its intercepted arc is twice that measure, so this is also 36 degrees. This is 18 times 2, which is 36. In short, these two are the same. Okay? It's kind of interesting AB is parallel to EF because I'm tilting my head to the side and those are not drawn to scale because you're saying, this looks bigger than that. It does look bigger than that because it is bigger than that, but not really. These numbers are the same. Nothing is drawn to scale. Don't make that assumption. So I guess something I could take home that I now know, when you have parallel chords going through, they have the same intercepted arc. That's probably always true. Measure of arc EF right here. Okay, this blue. Okay, what I'm looking at here is a semicircle in red. I'm going to erase it in a second. But AFB is a semicircle because this is a diameter. And I have measures right here, 36 and 36. So 36 plus 36 is 72. This is my unknown, x. So 180 minus 72 equals x, which is 108. Cool, 108 degrees. That's a little thick. I'm going to write it like this, 108 degrees right there. Measure of angle ADB. Okay, this is a diameter. An inscribed angle intersecting at the diameter with its endpoints is 90 degrees because its intercepted arc is a semicircle. So it's half that measure, that's 90. All of those are always 90 degrees. Don't need to practice anything else with that one. Measure of angle AFE. Okay, we already figured that one out. That one's 18 degrees. Inscribed angle again. And so let's see, I'm trying to figure out how would we figure this out before figuring out that doesn't matter. But the way we figured out is whatever it is. Sometimes they don't do these in order, I guess. Measure of arc AC. It's this guy in red right here. Okay? Part of a semicircle. ACB is a semicircle. This part is 52 degrees. So this is 180 minus 52, which is 128. So this is 128 degrees right there. And finally, measure of arc ABF. That is the major arc as displayed in purple right here. ABF. Okay? ABF is 180 plus 36. It's not much more complicated than that. I was looking at this and saying, uh-oh, I'm going to have to know this angle, which doesn't make much sense. 180 plus 36 equals 216 degrees. Okay? Two more problems. Find the value of x and y in the circle A, show all work. Okay, now these are arc measures, I assume. I don't think they're lengths, because they don't have any lengths here. So, vertical angles, 87 and 87. That won't much matter. What I do know is going back to my circle stuff, way up here, you will see that you have two arcs, R and T, and an O and a theta on the inside right here. Theta is equal to the sum, to half the sum of these two arcs, R and T. Now you have to make sure that it's the well, not the central angle. It's the angle that, the vertical angles that go out to these intercepted arcs, not these ones over here and here. Because I think a test fooled you on that once. So it's just something to be careful about. So 87 degrees equals half the sum of 3x plus 15 plus y. Now, we can't solve for anything just yet. I can simplify that later. But let's do this first. I didn't recognize that would happen. Well, hang on a second. Okay, here you have a semicircle. Because this crosses through center A, so there's your semicircle right there. So 3x plus 15 plus 2x plus 5 equals 180. Okay, combine like terms. 5x plus 20 equals 180. 5x equals 160. So x equals 32. So x is 32. Now you can use that x, plug it into here, solve the rest of this equation. So I'm going to do two things at once because I'm running out of room. Multiply both sides by 2, and I'm going to plug in 32 as I do this. So 2 times 87, so the 2 and 1/2 cancel out. 2 times 87 is 174. So 174 equals 3 times 32 plus 15 plus y. 3 times 32 is 96. 96 plus 15 is 111. So 174 equals 111 plus y. Subtract 111. Y equals 63. 63 and 32. There and there. So that's solving for x and y using two different properties there. Okay, last problem. I want to finish this off. Circles A and D are tangent to one another. Okay, when they're tangent to one another, that means they cross right at one point right there. That's not going to help for too much except to know that the radius right here plus the radius right here is that length. So if they give us these radii, that's going to be perfect. So let's see. I'm going to go ahead and draw kind of that radius there anyway, though. Do it in purple again. Oops. So this right here is this AD right here is this radius of one plus the radius of the other. Okay, this isn't really coming out very well. Anyway, I'll keep it like that. EF is tangent to both circles, so now you also automatically know right angles here and here with the radii intersecting with them. If AE is 3 and DF is 5, perfect. AF is 3, DF is 5. This together is 3 plus 5. So AD is 8. Okay, because that's radius plus radius. Then find EF, show all work. Okay, this is going to be interesting. What I do have here is a quadrilateral, but not only a quadrilateral, I have a trapezoid. Okay, not that that's going to mean too much for you. What I'm actually going to do is divide this trapezoid into a rectangle and a triangle. The reason is because I need to probably use Pythagorean Theorem to find out this stuff here as I do this. So if I draw a rectangle here, which means I make right angles right here. Now, none of these really look like right angles. It's not all drawn to scale. But mark my words, if these are right angles here, then these also, when I create the rectangle, also must be right angles. So if that's a right angle, then this is a right angle right here as well. Okay, in a rectangle, you have congruent opposite sides. If this is 3 right here, then this is 3 right here. If this is 3, then this is 2. Okay. I can't explain my creativity process through this entire thing, but you have to understand, if I'm trying to find the length of EF, finding the length of AD, or I'm sorry, not AD, but this right here will help me determine all that. Now this is a rectangle, this is a right triangle. I'm going to redraw this right triangle upwards because this is the way we better perceive them. We have a right triangle with a leg of 2 and a hypotenuse of 8. I don't know this length here. If I find out x, this will also be x. Okay? Again, I'm just showing you the work. I'm explaining what I did, or I'm showing what I did, or what I'm doing, but I won't be able to get the creativity out of it. That's something you're going to have to recognize as you do a problem like this, unfortunately. So x squared plus 2 squared equals 8 squared. This is one of those situations where this is not a special right triangle. So we have to solve for it. X squared plus 4 equals 64. X squared equals 60, so x is the square root of 60, which is square root of 2 times the square root of 30. I'm sorry. Well, I mean, that's true, but let's see, square root of 15 times square root of 4. Let's do that. Which is 2 times square root of 15, 2 root 15. So the length of EF is 2 root 15. If this is 2 root 15, so is that as well. So I'll try and explain it one more time, but I don't want to cut this out. Let's do this all one at a time. This length is 8, because this is 3 and this is 5. Those are radii, so this was 8. Now I have a trapezoid right there. If this is a trapezoid, then that means I can divide it into a rectangle plus a triangle, or 2 triangles in some cases, but that was a right trapezoid with right angles here and here, and obviously here and here. If this is a right angle, and this is a right angle, all that good jazz. It keeps working through, build the right triangle. This is 3 because it's a rectangle, all that stuff. Look back at the previous work I did before. I think it'll make more sense just by looking at it than me re-explaining it. Okay, so that's all the stuff there, and that's Unit 10. And so that's kind of everything. I might do one more video some other day for as far as review stuff to make sure that you get other stuff we've talked about, things that didn't get covered in these reviews. But hopefully with the circle stuff, these practice problems make more sense and you got more things with them. One thing I do want to emphasize is this length thing, though. If they ask for length of AB, it is not the arc, it's the actual length, measuring tape like length. So keep that in mind. Okay, I want to sign off.